In this episode, or this video, I'm going to talk about linear functions and do a little introduction on what linear functions are, and then work through the linear function review sheet that I posted online for my classes. So here we go. So a linear function is a function. I mean, as the name indicates, it's a function whose graph is a line. That's why they call them linear functions. And the basic format of a linear function is generally you start somewhere and then you add the same thing over and over again. And that's, of course, if you remember, fast adding is multiplying. So in other words, we can add 2 over and over again by multiplying it by the number of times it's been added, right? So you can see that the way this works is, f of 0 would be 5. F of 1 would be 5 plus 2, which is 7. F of 2 would be 5 plus 2 plus 2, which would be 9. F of 3 would be 5 plus 2 plus 2 plus 2, which would be 11. And you can see that each time I'm stepping up by 2, aren't I? And we call that a slope. So I'm starting at 5, I'm adding 2. Of course, if it was f of x equals 5 plus 1/2 x, well, that means I'm stepping up by half each time. So again, if I do f of 0, that's clearly 5. F of 1, that's 5.5. F of 2, that's 6. And again, you can see the step up. So, and we call that step up the slope. And this is called sometimes the initial value or the y-intercept, because that's what happens when x is 0, we get 5, and that means that you're on the y-axis. So that's kind of a brief introduction to linear functions. And so when you're writing the equation of a linear function, there's really 3 different forms that we mainly think of. Slope. I'm going to scratch that one out, but slope-intercept form is one that most people are most familiar with. That's y equals mx plus b. Whoops, that's supposed to be a plus b. Where m is the slope and b is the y-intercept. So if the equation is in that form, like you can see, this is kind of that in form, although I got the m and the mx and the b switch around. So here, this would be the b, and that would be the slope, right? Same thing down here. So that's slope-intercept form of a line. We have another one called point-slope form of a line. I'm skipping down here. So that's y minus y1 is equal to m times x minus, x1, where once again m is slope and x1, y1 is any point on the line. So this is actually probably the most useful formula of the linear equation, because it's, as long as I know a slope and a point on the line, I can write the equation. Standard form is often thought of as like the most pretty form, I guess. It's ax plus bx equals c. And so standard form means that you have, no, I'm sorry, ax plus by. So standard form is when you have x and y on one side and you have nothing but integer coefficients. So a, b, and c all have to be integers. So in other words, if you have a function that looks like this, 1/2 x plus 1/4 y equals 3, that would not be considered standard form. You'd want to change it. If you wanted to change the standard form, you'd have to multiply both sides of the equation by 4. So then you'd end up with a 2x plus y equals 12. And then that would be in standard form, because notice the integers are, the coefficients are integers. Okay? Okay, so now I'm going to run through some of these examples and we'll kind of flesh out what it looks like to graph linear equations and what it looks like to write a linear equation. So in this one it says sketch the graph of each line. Now of course we can sketch that by just making a little table. You all have made tables before, right? And just like we've talked about in functions, there's an input and output. So I can input anything I want, like I could input 5 for x, for example. Why did I pick 5? Because I know what 5 times 1/5 is. It's pretty easy to do in my head. So because 5 times 1/5 is 1, 1 plus 3 is 4. So that means the point 5, 4 is on the graph. So if I go over 5, up 1, 2, 3, 4, and put a dot. Whoops, sorry. That point's on the graph. Maybe blow this up a little bit so you can see it better. And I could plug in, say, 0. That's usually a pretty easy one. 0 times 1/5 is 0. 0 plus 3 is 3. So I can go down here to 0 and up 1, 2, 3 and put a dot. And I could draw a line. Why do I only need 2 dots? Because I recognize this is a linear equation. So all I need to do is find up 2 dots. Now, there's another way to do this if you understand slope-intercept form. Remember we talked about up here, this is slope-intercept form, and we know that the b is the y-intercept, and the m is the slope. So when I look at this, I should be able to recognize that as slope-intercept form. So 1/5 is the slope, and 3 is the y-intercept. So the slope being 1/5 means that it's going over 5 and up 1. So all I need is a point on the line, and that's what this gives me. This is the y-intercept, which means it crosses the y-axis at 3. So this slope is telling me from 3 I can go over 1, 2, 3, 4, 5, and up 1. Notice it hits the same spot. Now also realize that a slope of 1/5, that's the same thing as -1 over -5, isn't it? Which means I could, instead of going to the right 5 and up 1, I could go to the left 5, 1, 2, 3, 4, 5, and down 1. Because that would be going -5, -1. Okay, so here's another example. This is also in slope-intercept form. So the -5 tells me that I cross the y-axis at -5. And then this tells me I should go over to the right 1 and down 5. But if I do that, I'm going to go off my graph. So instead, I'll go to the left 1 and up 5. And go to the left 1 again and up 1, 2, 3, 4, 5. And then I can draw a line. Sorry, that was kind of wavy. Okay, because again, why can I go to the left? Because -5 over 1 is the same thing as 5 over -1. Right, so this would mean going to the right 1 and down 5. This would mean going to the left 1 and up 5. Okay, moving right along. This is an equation in standard form. So I could put it into slope-intercept form. Let's do that real quick. So that would be -2y is equal to -3x minus 6. I just subtracted 3x from both sides. Divide everything by -2, and I get y is equal to 3/2 x plus 3. So that means I can cross at 3, and I'm going to go, and this says to go over 2 and up 3. Or go to the left 2 and down 3. And once I do that, I can see a nice clear line come through. Now again, I could have done that. I didn't have to put in slope-intercept form. I could have done a little quick t-chart and put in, for example, 0 for x. If I put in 0 for x, then y has to be 3. And then throw a 0 in for y. And then x would have to be -2, wouldn't it? Because this one's pretty easy to throw zeros in for x and y and find your other answer. So, and notice 0, 3 is right there, and 0, -2 is right there. So it would give me the same line. Okay, this one, I could do the plug-in x and y, 0 for x and y, or this one's fairly easy to just change to y equals -2x plus 4. So put it in slope-intercept form. So that means I'm going to go, I will cross the y-axis at 4. And the slope is -2 over 1, so that means I go to the right 1 and down 2. And again, with the way slope goes, it keeps going like that. So I could draw as many of these dots as I want, to the right 1 down 2 to the right 1, down 2 to the right 1, down 2, etc. And I also could go to the left 1, up 2. That produces the same result. Oops, I missed, didn't I? I'm supposed to go through there. Okay, moving on semi-rapidly. Okay, here's another example. I'm going to go ahead and shut the video off for a minute and do these real quick and then come back on. Okay. Okay, both of these I just put them in slope-intercept form. Notice there's y equals mx plus b. You can see it, and here it's y equals mx plus b there. So the y-intercept is in both cases 5, so I started at 5. In this case, the slope was -3/2, so I went over 2, down 3. And here the slope was 7/3, so I couldn't go over 3, up 7 because it'd go off the chart, so I went to the left 3 and down 7 to get that dot done there. All right, now we got to write the slope-intercept form of the equation line. Okay, so in this case, I'm going to write an equation. So I want it to look like this. And so in order to write this equation, I need to know the m and the b. Of course, the m is slope and the b is y-intercept. So I can see the y-intercept right there. It's crossing at 5. So then I just need to know the slope. So I'll put a little 5 there to remind myself. And then I just got to find a lattice point, like maybe right there. And so it looks like I'm going over 1, 2, 3, 4, 5. That'd be 5 on the bottom. And down 1, 2, 3, 4, 5, 6, 7, 8. So that'd be -8. So that would be my slope. Y equals what's going on there? Equals -8/5 x plus 5. Okay, same thing here. I'm going to just spot the y-intercept, which in this case is 4. You can see it right there. And the slope, it looks like I'm just going over 2, up 1. It looks like. Does that look like it? Yeah, over 2, up 1, over 2, up 1. You can see it there. So that means y is going to equal to 1/2, because I'm going over 2, up 1. The change in y is always on top, change in x is always on the bottom. And the y-intercept was 4, we said, plus 4. Okay. So this is write the point-slope form of the equation of the line through the given point with the given slope. So here they're giving us some point. Notice it's not the y-intercept, it's just some other slope. So we're going to use that point-slope form of the line, which is right up there. Okay. So I just go y minus y1 is equal to m times x minus x1. And remember, m is the slope, and x1, y1 are the coordinates of some point on the line. So this would be y minus a -1 is equal to -2 times x minus 1. And this said write the point-slope form of the equation, so we could just leave it like that. Although you know that you could put it in standard form or slope-intercept form any way you want to, just by simplifying and moving some things around. So the same thing here. This says the slope is 0. That's kind of a tricky one. So that means I'm going to go y minus -3 is equal to 0 times x minus 3. But of course 0 times x minus 3 is just 0, so we get y plus 3 is equal to 0. Which is the same thing as y equals -3. And I don't know if you remember this, but that is a vertical line. I'm sorry, a horizontal line, which makes sense because the slope is 0, means it's not rising at all. Okay? Now, number 11 says write the slope-intercept form of the equation of the line through the given point with the given slope. So in this case, I would just go y minus a -1. Come on. Y minus a -1 is equal to -3/2 times x minus 2. Of course, that's not in slope-intercept form, so I just need to change it to slope-intercept form. So that'd be y plus 2 is equal to -3/2. So I'm going to distribute the 3/2 plus 3, it looks like, because 3/2 times 2 would be 3, right? And a negative times negative would be positive. Then I'm going to subtract 2 from both sides, and I get y equals -3/2 x plus 1. So I'm just subtracting 2 from both sides because I'm trying to get it in that y equals mx plus b form. Okay, same thing here. I'll start off with y minus a negative 2 is equal to negative 1/2 times x minus 0. So that's going to be y plus 2 equals negative 1/2 x, which means y equals negative 1/2 x minus 2. That would be slope-intercept form. Slope is negative 1/2. Y-intercept is negative 2. That means across the y-axis at negative 2. Alright, now it says write the standard form of the equation of the line through the given point with the given slope. Alright, so again, once again, I would just start by going y minus 1 is equal to the slope, which is 1, times x minus a negative 1. And that's y minus 1 is equal to x plus 1. So now this time, standard form, I want x's and y's on one side and numbers on the other. So I would subtract x from both sides, so that'd be y minus x. Add 1 to both sides, so that would be 2. So y minus x equals 2. Do the same thing over here. Y minus 3 is equal to the slope, which is negative 8 times x minus 4. And if I simplify it, the right side and by distributing negative 8 through, negative 8 times x is negative 8x. Negative 8 times negative 4 is positive 32. And again, I want to get the x's on one side and the numbers on the other. So that'd be y plus 8x is equal to, and if I add 3 to both sides, I get 35. So that would be slope-intercept form. Now it says write the slope-intercept form of the equation of the line through the given points. Write the slope-intercept form. So once again, I'm going to want this when all is said and done. But I'm not necessarily going to go there first. I'm just going to go y minus, and now remember the point slope form of the line requires a point on the line. So it doesn't matter which point, so I'll just pick the first point. So that'd be y minus 5 is equal to m times x minus 0. Now the problem here is they didn't give me the m. But remember, slope is just the change in y, how much the difference in y's, over the change in x. And so if we just pick 2 points on the line, we can see that from this point to that point, the y changed, it went down 1, so I put a negative 1. And the slope, or the x values, went up 2, didn't they? So this went from 5 to 4, so that's why it's negative 1. This went from 0 to 2, that's why it's positive 2. So that means the slope is negative 1/2. So I take that m out, put in a negative 1/2 there. And if I want to put it in slope-intercept form, I would just go y minus 5 is equal to negative 1/2 x, which means y is equal to negative 1/2 x plus 5. Okay, so you get the idea of changing it to different forms. I'm not going to keep doing that for all of them. I'm just going to write the equation. So in this case, I'd find the slope first probably. So slope is equal to change in y, that it went from negative 5 to negative 1. That's down 4. I'm sorry, no it's not. It's up 4. Positive 4. And from negative 4 to negative 1, that's a positive 3. So then I'm going to go y plus 5, because minus a negative 5, is equal to 4/3 times x plus 4. And of course you could distribute the 4/3 through and put it in slope-intercept form. And so, yeah, I'm going to do this one offline in a minute. I'm going to hop down here and I'll talk about these. So the other thing to remember about lines is lines that are parallel have the same slope. So when they say write the slope-intercept form of the equation of the line described, so we want a line that goes through this point, but it's parallel to that. So basically all this is telling me is the slope is negative 8. That's all it's telling me. So then I'm going to go y minus 4 is equal to negative 8 times x plus 1, because x minus negative 1 would be x plus 1. And if I want in slope-intercept form, I could just put it in slope-intercept form. Negative 8x minus 1 plus minus 8 plus 4 would be minus 4. Okay? So parallel lines have the same slope. Perpendicular lines have the negative reciprocal. So the fact that this is telling me that the slope of the line I'm interested in is equal to negative 1/3. And same thing on here. Since it's perpendicular to this line, that means the slope of my line is going to be positive 3/5. So you change the sign and flip it over when you're talking about perpendicular slopes. Okay? Actually, I think the answers are down here, aren't they? Yeah. So you can check your work on those. I think I've done talking about that. Let me do a couple inequalities and then we'll be done with this. Okay, so graphing inequalities are just like graphing linear equations. So like in this case, I'll treat it like y equals mx plus b. Go down to -5, put a dot, and the slope is over 1 up 5, over 1 up 5, over 1 up 1, 2, 3, 4, 5. And now, but notice it says y is greater than 5x minus 5. So that means I'm looking for y values bigger than this line here. So the way I'm going to indicate that is, first of all, I'm going to draw a dotted line indicating that we don't count the line. That's not part of the answer. And then since this says y is bigger than the line, we're going to shade up here. So your answer here is it's a whole region basically. And notice this one, that was strictly greater than, this is less than or equal to, so when I draw the line it's going to be solid. So I go to 4, put a dot, and this says go over 1, down 3, over 1, down 3, over 1, down 3, etc. And this time I'm going to draw a solid line because I can include the line. And it says y is less than it, so I shade below the line. Okay. Here's some linear graphing. I'm sorry, some systems of equations, but we can use graphing. We've already talked about that, so you can do that. And then this is system of inequalities. This is just kind of a fun little extension of what we're talking about. So in this case, you're going to graph the first line, which is -2 and over 1 up 1, 2, 3, 4, 5. And it's greater than or equal to, so I'm going to draw a solid line and then shade above. And then I'm going to change color because I can. And I'm going to graph the other one. So it crosses at +2 and has a slope of 1, so that means it go over 1 up 1, over 1 up 1, etc. And it's strictly less than. So I'm going to put a dotted line and shade below, because y is less than the line. So then I'm going to go like this, right? So then if we're trying to solve this system of inequalities, the solution is actually going to be, I'll choose a different color for the final solution. Maybe I'll highlight. The final solution is this yellow right here. It's a place where the red and the green overlap. Isn't that cool? Okay. And like I said, the answers are there, so I think you get the idea. Hopefully that was helpful.